right, here we go with part 1 of the Unit 2 test preview. Again, we're splitting this into 2 parts as we'll be doing on the test itself, so get locked in here. All right, we're going to start with graphing parabolas. Again, we got cheat sheets for this, which I am not going to be referring because I'm doing my practice and I know what I'm doing. So when we're in standard form, we start with x equals negative b over 2a, and again, or the opposite of b. So since my b value is the value in front of x, the opposite of negative 2 would be 2. And then my a value is the value in front of x squared. So 2 times 1 is also 2. So my x value is 1. So when it comes to getting the rest of my values, I have choices. One of my choices would be to grab my handy-dandy calculator, get my y equals going here, type in my original expression, pop up the chart, and if I've calculated my vertex correctly, I should see symmetry over on the y side, which I can. So here I see that my vertex would be at 1, negative 3. And if I wanted to, I could go ahead and make a chart of my values. If you just want to plot them at this point, you could. But I'm going to go ahead and put some in a chart here so we can actually see the symmetry that's working. So I can go ahead and get that drawn in. And then the last part I have is my axis of symmetry, which again is the x value of my vertex. I have to put the x equals with it. You can't just put 1. 1 is a number. 1 is not an axis. 1 is not a line. 1 is just 1. So that's all I can do for that first problem. When I get to number 2, vertex form. Now this should make life easier on me. My vertex is the opposite of h and k. Because again, when I look at this originally, opposite of h, keep the k. It doesn't mean make it plus, it just means keep the value the same. You're like, okay, so negative 2, negative 1. And again, if I want to, I could grab my calculator out. Take a look at my chart, see my symmetry. And graph my parabola. Now, as far as focus and directrix go, even though you do have your sheet, remember, we've got the formula right here for you too. So I have to remember, let me pull this back down for a minute, that my a value would be the number in front of the parentheses. Since I don't see 1, my a value is going to be 1. Additionally, for h and k, those are just my vertex values. So when I go to calculate this, it's h, and then I'm going to do a little work under here before I put the answer in. So k plus 1 over 4a. Now, here's where the problem lies. And we've talked about this before. Some of you are going to try and put this straight into the calculator, the whole thing. You're going to get a different answer, and you're going to be like, ugh. So, better choice. What's 4 times 1? 4, right? So let's at least get to this part before we consider going to a calculator. And I really think you could do negative 1 plus 1/4 in your head as long as you've ever dealt with like money and quarters and things. But let's just say you're not feeling comfy. Make sure you keep your fraction in parentheses, because if you don't, you're not going to get the right answer. Okay, and if you want to go to a decimal, I will not jump up and down and scream. I'd prefer negative 3/4, but, we pick our battles. And then I do the same thing for my directrix. k minus 1 over 4a, which is 1/4. And again, if you want to put that in the calculator, you can, but I mean, this one's even a little more obvious. Negative 1 minus 1/4. Negative 1 1/4. Or negative 1.25. I'll take either, even if you do a decimal here and a fraction here. As long as it's the equivalent, I don't care. And that's fine. So that's all as far as our graphing goes. Okay, solve by factoring. Notice it doesn't say solve by the quadratic formula, not solving by finding a zero, not solving for anything else. Solve by factoring. You must know the Algebra 2 F word. And that's all there is to it. Okay, diamond problem. At least those are easy. My two numbers multiply to 18, which means they're either both positive or they're both negative. How do I know? I look at the sign in the middle. Since that's negative, so are these. And now I'm looking for a pair of numbers that multiply to 18 but add to 9 because the signs are the same. Now, do I have to write out that list if I can figure it out in my head? No. But I like to put that out there. And again, solve. Figure out what x is. Even got blanks here to remind you. Don't leave it like this. Set each of those equal to 0. Add my 3. Add my 6. And I'm good. If I go to my cheat sheet, and I'm going to refer back to them again. Grab my packet here. Now I look at this next one and I'm like, okay, it's two terms. They don't have anything in common. So what the heck am I supposed to do? Well, there's two terms. Okay, difference of squares. Wait a minute. 9 and 14. Oh, they are squares. Okay. So I need to figure out, what do I square? What do I multiply by itself to get each of those values? Because those are the two values that I use in my little expression here. My spot that goes in A would be my 3x, and the B would be my 7. So 3x plus 7, 3x minus 7. And why are they opposite? Because I want to multiply to a negative. And then again, just set each of those equal to 0, and take your time working your way through. Make sure you get to the right answers. Now this last one we got choices. Easiest way would be if I recognized that these were both perfect squares and just dealt with it quickly that way. I'll talk about that in a minute. But I'm going to do what I assume a large majority of you are going to do, and you're not going to realize that or see it. You're going to slide and divide instead. And there's nothing wrong with that. You still can get to the right answer. But now you're like, okay, well, at least I know it's positive. That's a good thing. But I don't know what to do as far as 400 goes. Well, when all else fails, we're going to start making ourselves a list. And we're just going to start working down until we find a pair it works. Now, they're 40 apart. So I don't know. Let's see. We're in 100. I'm getting closer. Whoops. 40 doesn't help me. Oh my goodness, Harty. Okay, notice they're getting closer, but I'm still not really near 40. Now I'm 30 apart. Now I think I've gone too far. Okay, 9, no. Or I was going the right way. They got to add up to 40, Harty. They're not 40 apart. They're the same sign. Goofball. Ha-ha. And that may be a process you have to go through. Okay. 20 plus 20 adds up to 40. But again, don't set those equal to 0 and tell me the answer is 20. Oh, that'd be such a shame. Because remember, this is slide and divide. And I need to reduce my fractions before I go further. And again, if you're not sure, little math interaction never hurts. Get my factoring part done. I've only got to deal with setting one of those equal to 0 because they're the same thing. And it took a little while, but I got there. And you're like, wait, I thought you said there was a way that I could do this faster. There is a way that I can do this faster. If I recognize that this is what's called a perfect square trinomial. And a perfect square trinomial means my first and last terms are both perfect squares. If I can recognize that, it's going to work a lot the same way that the perfect squares works. I square 4x to get 16x squared. I square 5 to get 25. I put a squared on there, and I steal the sign from the middle. 4x plus 5, 4x plus 5, 4x plus 5 squared, which is the same thing. Kind of slick, huh? Just a thought. All right. Solve using square roots. Don't forget the plus minus and reduce the radicals, which means no decimals. Thank you very much. So when you take the square root when x squared is alone, when you remember that it's plus minus, not only because I told you, but also because you know that a degree of 2 would have 2 roots, but you do not, let me say this one more time so I can make sure it's understood. Don't you dare write plus or minus 4.9. Okay? No. Just no. You need to look in your list of perfect squares. So we're back to the sheet again. 2 numbers that multiply to 24. One of them is in this list. And in this case, that would be 4. Okay, the 4 is the only one that's perfect, so it's the only one that gets to break down. The 6 has to stay underneath. And I'm set. And it's going to be the same way on number 7. Don't square root right away, though. We've got to isolate the x squared term. So I'll minus the 8. Still not ready to square root. I'll divide by 2. Now I'm ready. Plus minus, because I'm solving a quadratic. 12 also breaks down. 4 times 3 is 12. And again, 1 always has to be a perfect square, otherwise this is kind of useless. Get my exact answer. Last one, and this was a doozy on our last quiz, so let's nail it this time and not have it get us. Here, I do not want to distribute the 3. Okay? I want to divide the 3 out. Okay? When I get here, I can't add the 3. The 3's in parentheses right now. So I got to get the squared off, which means I need to square root it. This time, we finally get one that doesn't break down at all. You're like, but 5 times 2 is 10. But 5 and 2 aren't on the perfect squares list. So don't do anything else. Add my 3 over. Again, not with the 10. Radical jail, no radical jail. All these little things to be keeping track of. That's, again, what I'm doing there. Again, just take your time. Remind yourself those things. All right. And to our other favorite, I. Only thing we need to remember with I squared equals -1, not I. Okay, I just stays I. I squared has turned into -1. So, if I see an I under a radical, I need to pull an I out. Once I take the I out, now I can break down the radical. And you should know this one by now. Square root of 100 is 10. So it's 10I. No plus or minus on those. They're not quadratics, they're just a radical that we're breaking down. Okay, when I get to 10 and 11, I can't stress this enough. People still did it on the last quiz, even when I talked about it. This is not multiplication. Do not FOIL these. Okay? The minus here just has to be distributed. So leave the first one alone. Distribute the -8. Change signs. Combine like terms while watching your signs. And I'm good. Okay, and 11 actually is a little bit easier, even though it looks like there's more. I do have to do more distributing, but at least there's no negative that I'm having to worry about. It's just remembering that I distribute those coefficients all the way through. Once I distribute those, combine like terms, and I'm set. And no, it wouldn't be marked wrong if you wrote -28I plus 34, but typically we write it in standard form, which is the number and then the imaginary term. All right. 12. Now we finally get to multiply it, because see, there's no plus or minus in the middle. Whether you're going to use classic FOIL and do it out like this, maybe you're going to make yourself a box. Again, you're just multiplying the pieces on the edge. Still have to watch my signs, though, when I'm doing this. The sign slip up would be pretty disastrous here. So I get that there. Remember, I squared is -1. So this is really -56 times -1, which is +56. And now I'm ready to combine like terms. 12 plus 56, 68. 16 minus 42 is -26I, and I'm good. Okay, no more combining after that. This has I, this doesn't. And then our last dealings with I, at least up here in the I only section, we have to multiply by the complex conjugate. And again, all that means is switch the sign on your I term. Not the other term, your I term. Do it to the numerator, do it to the denominator. A little distributing. Now over here, again, I need to do my due diligence. I got time. Classic FOILers, you can do your thing too. So let's see what we got here. -9 times -1 is +9. 4 plus 9 is 13. 6i minus 6i just cancels. As far as I can go. Okay, no i's in the denominator. If you do something and there's still i's down there, you've done something wrong. You did something wrong. I shouldn't speak incorrectly. I'm a teacher. And then the last couple for this first part of the review, solve again by taking the square root. So I need to isolate my squared term. So I'm going to add 11. Again, adding something to a negative brings it back closer to 0, so don't go to negative 49. Am I ready to square root yet? No. Got to get 3 out of there first. Now am I ready to square root? Absolutely. So I take that square root, and 2 things. It's a quadratic, plus minus. There's a negative under the radical. Pull an I out, which actually makes this I square root of 9, which would be 3i. No radical left on the 3. We broke down the square root of 9. It came out perfect. And we're set. And then our first flashback to completing the square of our many ways of doing this. Again, you've got your song sheet for this one. So let's see. No, I'm not going to start singing. I'm just singing it through to myself. X's alone. All right. X's alone. Need to find B. Complete the square. That's all you need. Sorry. All right. So we're going to have B. We're going to square half B. Okay, so that 9. It goes once on each side. Now, I go from my perfect square trinomial to my square of a binomial. Just putting the b divided by 2 number in there with it. And now I'm ready to actually finish this off and start solving. Again, square root to get rid of the squared. It was a squared, though. It was a quadratic, so I got to have plus minus. 17 does not break down in a useful way for me. My last job is to get 3 out of there. Oops. Okay. This concludes part 1. Now again, we went into some detail on this as we were doing these. It's not like I was just running through it 100 miles an hour. And we're still at just a tad under 23 minutes. So when you get this coming up on the part 1 of the unit exam with this many questions, there's no need. We're not getting done in class. Okay, no more of the stretching out stuff. Part 2 coming your way tomorrow. See you then.